In this video, we'll be going over the Dell application request routing replacement using F5 technologies. A quick overview, of course, the purpose is to replace Dell's existing ARR solution, but we need to provide a solution that eliminates the requirement for potential outages and can delegate some of the roles and responsibilities to the BUs or app teams that make up Dell.com. The goal here being that any particular update or upgrade of an underlying application request routing policy does not have an impact across the entire Dell.com domain. So when we look at our solution, what we're proposing is actually a two-tier design. The current design leverages the traffic distribution and SSL decryption. This is similar functionality that the F5 Viprions play today, and actually we would continue to use this hardware in the proposed solution. This would be considered our tier 1 and would do the majority of the heavy lifting and initial URI routing. Now, tier 2 would be a per application proxy. This is where the individual business units, teams, or service owners can control their application request routing policies themselves. This can be built either through the F5 GUI, it can be tied in to GitHub or GitLabs via webhooks, so they can maintain a JSON declaration inside a code repository. They can also use existing CI/CD pipelines to automatically update these configurations on their per app proxies. And finally, the teams can make the API calls directly themselves. This supports a pave and nuke deployment and upgrade for seamless lifecycle maintenance. Now we could talk a little bit about the requirements. In this demo, we'll cover use case 1, which required URL rewrite and URL redirection. For the rewrite example, we'll look at a URL that contains the model/laptop name or model number, and we will rewrite the backend request to mystore1234 with the model number. So let's take a look at this particular example. We'll run our unit test. As you can see, we requested the models/the model number, but the backend Apache server received a URL request of /mystore/1234 and then the model number. Now we'll take a look at the redirect example. In this particular case, it will be very similar, except the user is shopping for the particular laptop, and there again, we will send them to the My Store, but this time the user's browser will perform the redirect. So let's take a look at our use case here. So as before, the user requested a particular URI, but this time they receive a redirect, and the location is now mystore/1234/ the laptop model number. So how did F5 achieve this? In our particular example, we're using the F5 application service extension. This is a declarative API that has a JSON declaration. In this declaration, we're defining our layer 7 policies. We have two policies here. There's the redirect policy and there is a rewrite policy. For our redirect, our conditions are looking at the request URI, and if the URI equals this particular value, then we'll perform this action. Now, since this is use case 0, we're starting with something very simple, but you can, of course, have multiple operations happening here. Now, in the particular action, we're modifying the response and sending the user to the desired location. As I stated before, since this is use case 0, we're keeping things very simple. In future use cases, you'll see how we can craft custom redirection locations. Now for the rewrite, we're now looking to see that the request equals a particular value. And unlike before, instead of redirecting the user, our action now is to replace the URI for the F5 to server communication. So in this example, the Apache server believed that the incoming request was actually to this URI versus the models. In this demo, we'll go over use case 2. In this particular use case, we're looking for canary capabilities to split traffic and maintain persistence to the appropriate pool. Now, F5 already provides this functionality for Dell in a production environment, but in this demo, we'll be showing how to do this using the application service extension, which is our declarative API. The second portion of this use case is the ability to perform unit testing of any layer 7 policy written without having to deploy the entire stack. So we'll do this using a header insertion, and the F5 will respond with the particular information about what policy was executed. So let's take a look at the first phase of this use case. Now, I'll actually use the browser first. I'll clear the site data, I'll reload my page, and notice that I'm sent to real server 2. I also have a canary percentage of 20%, and if I refresh, I will always come back to real server 2, as you see up here in the title. Now, this would be an example of what a real user would experience. We have persistence that's being maintained, so the user is always being sent back to the pool member that's chosen based on the canary percentage. However, curl will let us do an example without maintaining persistence. So I've created a script that will execute curl, but it'll simulate a unique request each time. So our first request, we get real server 2, second real server 2. I'm going to keep doing this, and we'll start to see that 3 will pop in our percentage. And there we go, real server 3. Now, for the second phase of this example, we're looking for unit tests. Now, for unit testing, I have a new curl command that's going to insert the unit test header. So I will simulate a request going to a /stats URL, and then a request going to /index.php. So for the /stats URL, we see that we've matched a particular rule. Let's take a look at our AS3 declaration to determine what that rule is doing. So here's my layer 7 policy. I have 2 rules, the first one being stats. Stats is looking for a URI that equals /stats and is redirecting the user to /index.php. So in this particular example right here, we see that /stats was requested, and therefore the rule was matched. Now, the second request is going directly to index.php. So we see that the canary policy is being matched. In this example, we see that the second rule is canary, and this is assigning a percentage based upon the request coming in on first request, not on subsequent. So the other way we can look at this is the output being provided. So when we look at this, instead of having to go look through log files, the F5 is automatically sending an HTTP response with any data that the developer would like to use as a unit test. In this example, I'm simply using what the policies were, what the rules were, but there's an unlimited amount of data that can be sent back on how this was executed or which particular pool member was used or which client requested the data. In this demo, we'll discuss use case 3. Now, use case 3 is by far the most complicated example, and it will leverage some of our more advanced features in the F5 application service extension, which is our declarative API. Now, in this particular example, we're looking for a URI, and we're looking for specific headers that are attached in that request. And based upon some of these headers, we're going to look up data in a key value pair. Now, the supplied request and redirect URL are supplied right here in the bottom of the page. However, the data sets that were also attached with these actually would never produce this URI. It's primarily the ZHTW. So in honoring the data, we are generating this exact URI, but we're generating it with the correct data that was provided to us to store in the key value pair, because ZH-TW was not one of those data sets. So let's take a look at the example. I make my curl request. In this particular request, we are requesting the URI, and this needs to be rewritten. Now, there's data that we have to pull from headers. One of the things we're looking for is that responsive is enabled, that we're not overriding for a mobile device, And then the LWP builder is the data that we're going to go look up on our key value pair. Now, based upon the LWP builder data, we determined that our location needs to be the DA-DK. Now, the rest of the URL matches exactly what we were supplied in the example. So we've rewritten the path as well as rewriting the query string to match the requested functionality. So what does this look like inside of the declaration? Well, like before, we have our layer 7 policies, but one of the things that's new is we're defining our key value pair inside of our declaration. Now, this key value pair can be updated. You can supply the entire declaration again, or if there's just a couple modifications you need to make, you can use an API patch. In that particular example, you'd only have to supply the key value pairs you want to add or remove. Now, inside the layer 7 policy, we're looking for some of the mappings that were done using the current ARR engine. So in that example, we're looking to make sure the path has the P in it as well as the PD. We're then making sure that our responsive enabled was true. We're also making sure that the mobile override was false. Now we're crafting our redirect location. Now, what you see here is the F5 looking inside the key value pair based upon the value of that header. And then we're also building in our URL query string based upon the data that existed in the query string that came into the F5. This was one of the requirements that you were doing in regular expression. Now, to me, the added benefit here is my developers or my engineers that are developing and troubleshooting this, they don't have to understand or read complicated regex. And this is all done in a human readable format. They're able to look at and know that here are the conditions, that based on these conditions, I'm looking for particular values, where I'm looking for the data, and if these are met, then I follow an action. Thank you for watching our demo video today. We look forward to the final presentation where we can answer any questions you may have and show you the roadmap and deliverables that F5 can offer and make this an easy transition.